stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is waveforms. Of course it is. That's all we had on the menu for the last month. And let's see where we are in terms of the waveform display. And if you're new here, hello, it's great to have you here. And what we are doing is real-time audio effects in Reaper. We are processing audio in real time in Reaper, and we have been focusing lately on the visual aspects of the audio plugins. So showing or trying to show what the plugin is doing to the audio turns out to be a complicated problem. In some aspects, more interesting and complicated than processing the audio itself. Anyways, here's where we are at. We have been working on this component that draws across the screen the waveform. And let me tell you, this was a ride. It was complicated to get here, but here we are. And one of the compromises I had to make on the last stream to make this work was a technical issue. Let's get into that. Again, I promised I wouldn't, but I will, because I cannot help myself. I need to make things right, or at least I need to know that I made things wrong for the right reasons. Let's get into the problem, why it happens, and what we can do about it. So the problem is, you see this red line here? This represents the right head. That's where we are updating this image that is the waveform. We are updating the image of the waveform across this line. And as this line is moving across the screen, we can sort of see it kind of jumping a little bit. It's jittery at some points. The reason for that has to do with the race. I am calling this a race condition. It's not really a race condition. It's just a shortcut that I took in the implementation. So there are these two things happening at once. The first is just the passing of time. As I am speaking, time is passing. It's time that's never going to come back. You should think about that. And the second thing that is happening is we are writing into the image. We are overwriting what was on the image. Now, this overwrite happens every time that we render something to the screen, which hopefully will be 60 times a second, because that is the frame rate that we asked Reaper to give us. So we are saying, please Reaper, try to call my GFX block 60 times a second and plot whatever I render on the screen. Great. But Reaper, first of all, is not necessarily going to call this 60 times a second. If the resources are low, it may drop the frame rate. And also, even if it does call the GFX block 60 times a second, there is no guarantee that the 60 times will be equally spaced. So 2 frames may be faster to render, and then another one will take a little bit longer. And I think that there are some guarantees in terms of timing, but no hard guarantees. So there are these two things. Writing, which is happening on the schedule of the GFX block, on the schedule of this, and the passing of time, and the two may not be 100% in sync all the time. For the most part, they are in sync. For the most part, this is smooth enough. It's not a big deal. It's not a huge deal. but it's not perfect either. And we could try to make this line follow the passing of time. It gets a bit weird and complicated, and we started implementing it, but we didn't finish because it gets a bit weird and complicated. So I just took the shortcut of saying, whatever, I'm using the write head as if it was based on time, even though it's not. It's actually based on the refresh rate of the screen. In the JSFX documentation, they even say that you should not be doing exactly this that I am doing. So last time I was writing, the last section that I was coding this, I was so annoyed that I thought, well, whatever, I will just leave it as it is. And I'm probably going to, but I want to do one last experiment before I drop this subject for good. I promise. This is what the last experiment that I want to run. The experiment goes like this. The point of the experiment is to see the difference between something that is based on time and something that is based on the refresh rate schedule. The experiment goes like this. I will have two boxes going across the screen, pretty much like this red line is going across the screen. But the red boxes will be moving across the screen in different schedules. One will be based on time. I will use time precise, and it's a similar trick to what we implemented before on the stream. The second box will be moving across the screen based on the refresh rate. So that's the intent, that's the plan. That's what we are up to. Let's get down to business. This will be an entirely new effect. It's just an experiment. I will call this experiment. And I don't need the library for this, I don't think. And I could use the library, so in case you don't know, this waveform display is part of a library that we are developing together. And I could use the library for some of the functionality, like the circular counter and whatnot, but that introduces overhead. So I want to see in the best case scenario, when there is no library, no nothing. The only thing in the code is this two boxes situation that I just explained. If that's the only thing in the code, that's the best case scenario because there's nothing else going on. Then maybe, depending on the result of this, we may bring the two boxes into maybe the waveform display and just plot on top of the waveform just to see if more things going on will affect the results. But to begin with, let's have just a GFX block, 600 by 800, it seems okay. And then, well, let's start by drawing two boxes. I will set the color to red, and I will draw a rectangle that goes from the coordinate 2020 down to, or not down to another coordinate, but it will have a size of 30 by 30. Then I will do the same, except that this one will be blue and it will be further down. It will be at position 60. Whatever. Let's see what this looks like. There are the boxes. Now, let's change the position of the red box, the x coordinate of the red box, based on the refresh rate. So now I have to think about where I want it to go. I think I will go up to like 200 or something, 200 pixels across. So this is going to be the x based on refresh rate. Oh, and I will set the refresh rate to 60 because ultimately that's the refresh rate I want to have for my plugins, because I want them to look as good as they can look. And the X refresh rate needs to update. Oh, Bo is here. Hello, Bo. How is it going? I'm doing well. And what is it that I'm coding? Well, I don't remember if you were here last time, but I took a shortcut when I was implementing the waveform display. This is what the waveform display looks like right now. I guess the quick answer to your question is, what am I coding now? Still the waveform display, because I think I want to dig deeper into some aspects. But anyway, so this is the waveform display right now, and I took a shortcut when implementing this. I think it's looking pretty good, but I took a shortcut. And this is the red line here, the right head, is based on the refresh rate of the screen, not on time. You probably have been here for some of the streams in which I cover this. So the idea is just there is this race condition between the passing of time and the refresh rate of the screen. And I took this shortcut, and it sort of looks okay, but it kind of jitters a little bit, and I want to see how much it matters. So I'm doing an experiment now in which I am just moving these two boxes across the screen, or at least that's what I will do. Right now they're not moving, but they will move. They'll move across the screen. The red box will be based on the refresh rate, and the blue box will be based on the passing of time. And we'll see if the blue one is smoother than the red one. That's the experiment. And if it is smoother, if the blue is smoother, then we will pursue this further. We'll try to maybe make the waveform display a little bit smoother by taking in account the concurrency between the refresh rate and the passing of time. If we learn that the two boxes are about the same, I will drop the subject. That's what we're up to right now. Then later we have the time, and I think we will, but you never know these things when you're experimenting with stuff. But if we have the time, then I will try to do rectified waveforms. And probably, I wanted to avoid it, but I will probably do different thicknesses for the contour. You may not even be able to see this because I just chose a darker shade of blue, but there is a contour here in darker blue, which makes the waveform look nicer, I think. But maybe we want thicker lines there, and that's a whole can of worms, as you know. So I may get into that today. We'll see. So let's update this X based on the refresh rate. That is very simple to do, actually. We just have to plus equals, and then we want to go up to 200, and we want to do that in well, how long? Let's say that we want to take 3 seconds to get there. So that is 3 seconds times our refresh rate of 60. And there it is. It's moving across the screen, and it should be taking 3 seconds, but it's taking a lot more than that, isn't it? Also, yeah, it's not wrapping around. Okay, so there is that. Now I have to take the X refresh rate. If it is bigger than 200, then set it back to 0. This way it is going to snap back. Okay, 1, 2, 3, snap back. 1, 2, 3. It works. Now let's do the same for the blue box X. I'll call this the passing of time. And we'll also update this similarly. One thing is for sure, the wrapping I want to happen exactly the same way. So X passing of time, and the updating needs to be based on the passing of time. So I think I will need to get a hold of the previous time I was here. Let's start with the current time. That is time precise. And I don't know why I am using camel case, because in JS Effects everything is snake case. Let me fix that real quick. And here we are. Now this is the current, we are not there yet. Current time. There you go. So this is the current time, and we'll also need a notion of the previous time, which will be the current time. But because it's at the end of the block, this is only going to be the current time on the next pass. So it will be the previous time. There you go. Now we need to do some computation based on the current time and the previous time. What is the difference between the current time and the previous time. This is how much time has passed. Then I will take this and I will multiply by, well, I guess 200 divided by this. Is my logic right? I'm not even sure if my logic is right, but I will run this anyway. If the two boxes are close to one another, then I got it right. And they're not close to one another, so I got it wrong. I think that maybe the time precise is given to me in milliseconds. It's given to me in seconds, so that's not the mistake. I guess the mistake is really this formula, so let's think this through. It's so nice when you can just think maybe this is going to be the formula and you put it on the code and it is the formula. It's so nice when that happens. It happens to me like once a year, but when it does, it's super nice. Okay, so how am I going to reason about this? Well, I want to know what is the increment, how much to the right I need to go. So suppose that the current time is 1 second, because this is the unit of measurement. It's given in seconds. So suppose that the current time is 1 second more than the previous time. That means that 1 second has passed. How much do I want to move in that case? Well, I want to move 200 divided by 3 times 60. Am I right? Yeah, I think so. So this is 1 times this, so that's about right. Well, what if 3 seconds have passed? If 3 seconds have passed, then I want to move 200 pixels. So let me get this straight. If 3 seconds have passed, I want to have moved 300 pixels. So that's current time is 3 seconds more than the previous time. Then 200 divided by 3 times 60, 3 times dash should have been 200. And it's not, because I am dividing by the frame rate. So maybe I should not, because this is not based on the frame rate anyway. And this division by the frame rate is kind of embedded in this situation here. Maybe. Still not, you can tell that I'm not on firm ground on this, but we can try. Okay, there you go, there you go. Now they're moving together more or less. And interesting things are happening. It's hard to really tell what's going on here, because there is this optical illusion. If something is moving, like let's say that they got super out of sync. I was not expecting that. Many interesting things are happening here. What do you all think? You watching this, what do you all think? What do you see? I see the following. The obvious first thing. They drifted out of sync, and they drift out of sync more or less, probably depending on the resources. So at one point the red was ahead and now it's way behind, and you can sort of see when the frames are being dropped, because then the red becomes more and more lagged behind the blue. It's so much behind now that it looks like it's ahead again. The blue is taking a lap on the red. That is surprising to me. I was expecting them to be sort of in sync, but one jittering more than the other, but they're getting super out of sync. Then there is the jitter. I think I see the blue moving across more smoothly than the red. I think I see the red jittering more because it's based on the frame rate, so maybe I'm biased and I know that I was expecting that. And there is also the problem that if the red is jittering, it may look like the blue is jittering as well, just because they're nearby. So I guess I will try to remove this from the perception here by just putting this way below. Maybe that helps. Yeah, let's just look at one at a time in isolation. And I may be biased because I know what I'm looking at, but it really does seem like the blue moves across more smoothly and the red is more jittery. What do you all think? You watching this, what is your opinion? Do you think that the blue is smoother? Well, and then there is the real problem of them drifting apart far away from one another. The problem in that is that it's unpredictable and it seems like the gap can be large. Oh, Joseph is saying hi. Hello, great to have you here. Try white color for both boxes. I will. No problem. Especially if the blue is kind of dark, isn't it? Against a black background, it doesn't work all that well. So here we are. They look similar. Okay. That's actually comforting. Because the problem of one jittering more than the other is something that we can deal with. We can use some space in the image as some dead space, and we are writing into that space. And because we are writing into that space, we don't display that space. So if one is jittering, if one of the, suppose that we have like the big image where we are drawing to, and we section this image, we leave a small space in the image, and this space is going to move in the image, but it's a small space, it's like a scratch space in which we are writing to. We are in the middle of writing to that space. So if there is any jitter in that space, it's okay, because we are not showing that scratch space on the screen. It's all part of the temporary image, the off-screen canvas that we are drawing to, and then we don't plot that part. So if there is some jitter, we can fix that by just adding this notion of a scratch space. And we even tried to implement this a couple times in the stream, and I failed because it's hard to get coordinates right, or at least it is to me. So, but the jitter is something we can manage. But the drift is much harder to handle, because if the drift is contained, let's say that the drift can only be at most 100 pixels. Okay, then we make the scratch space 100 pixels. But if one is drifting from the other unboundedly, it can go and drift further and further apart, and one can take laps around the other. That no amount of scratch space can save from that. And it seems to be okay now. One is ahead of the other, but not by much. And now it seems like it's behind the other. It seems to have to do with the movement of the mouse. It seems like if I am interacting with the computer and I'm doing stuff, then I have fewer frames to devote to the UI here. I think I can make, yeah, just by moving the window, my computer is doing more things because I'm moving a window. And then I can make the top one lag behind the one below, like by an arbitrary amount. See? I'm almost making them meet again. So the drift can be unbounded. No amount of scratch space is going to fix that. Bo is bringing up a good point, actually. The YouTube compression and the quality is probably helping on the perception for you all, because the YouTube stream is at 25 frames per second, and the quality of the image is not as crisp as what I have in front of me. That affects your perception for sure. But you know what? I don't think we can do anything about this. I was thinking of the solution for the jitter, but the solution for the drift, I cannot think of anything. Because over time it's gonna accumulate and, you know, oh, but hang on. This experiment is not 100%. Yeah, there is a problem in the experiment. Let's talk about this. I thought of this experiment as a way to measure the jitter. And then I looked at them drifting apart, and I started talking about that. But the problem is this doesn't measure precisely what the effect of the drift. Okay, there is hope. Let's think through this together. So first of all, the jitter. Is it substantially different? I don't know. When I had them side by side, it looked more different. Now that I look at them in isolation, I can just look at the top one and just look at the one below. They kind of look the same to me. And then the problem of the drift can actually be addressed, because the way I am writing this experiment, the way that I'm updating the refresh rate here, this X refresh rate, the way that I'm doing that is purely based on the refresh rate. And that's not 100% fair, because the way that we are doing it on the waveform display is different. Every time that we run, we update the write head based on the read head of another circular buffer that is based on the sample block. So I will do something similar to that, but it's not quite the same. But the thing that I'm going to do is I'll just call it the circular buffer index, because this circular buffer index is just updating based on its own schedule. So let's say that it's updating, let's say 100 samples. Hopefully the circular buffer will be smaller than the screen. So it's updating on its own schedule, and here we are not actually doing anything to the samples, but in the real waveform display, this circular buffer index is really an index into a circular buffer where we are pushing samples to. So a sample comes in, we push that sample into the circular buffer, and then we grab the sample in the GFX block. That's what's really happening on the waveform display. And now we won't update the screen purely based on the refresh rate. We will do the thing that the waveform display is doing. So that is, we want to have, this is going to be the circular buffer write index, because we will also have a circular buffer read index. Yeah, let's do that. So while the circular buffer write index is different from the circular buffer read index, okay, I think that's it. So now we have a write index. We are pretending to be writing into the circular buffer that allows the communication of samples between the audio thread and the user interface thread. So we are pretending that we are writing samples into a circular buffer. Then on the GFX block, we have a read index into the circular buffer that is trying to catch up to the write index. As long as they're different, I am going to keep incrementing them. Oh, and I do need to wrap it back. And of of course, it has to have the same boundary as the write index. So the read index is catching up to the write index. And as it's doing that, it is also updating this. I wonder if I should add 1 here. I don't think I should add 1 here. I threw away the formula from before, but I think it should be similar to that. Yeah, I think it should be something similar to this. Oh, and I probably don't want to just set all the things to 0. Well, the read and the write index are incremented in steps of 1, so I don't have to worry about that. But the x's are incremented in steps that are not of 1, so zeroing them may glitch things as well. I will instead have a width variable and this way they are not resetting to 0, they're just going 200 pixels to the left, which is the more correct thing to do, I think. Now I'm starting to reason about fractional pixels, which is not ideal, but still. And if I'm giving these variables, if I'm creating a width variable, I might as well just create a duration variable, and that's 3 seconds. And a refresh rate. And a circular buffer size. No more magic variables on my code. There you go. What else? Well, it's always comforting for me to rename some variables and establish a naming convention, so I'll do that. And I did that. Okay, so now this is updating based on the relationship between the audio thread and the video thread, not purely based on the UI thread, not purely based on the refresh rate. And the reason why this version, I didn't refresh yet, so this is still the old version before I wrote all of this down. So this is the old version. On the old version, the problem is once I drop a frame, there is no recovery. Once I drop a frame, this box is going to be behind that one forever. And that's why I can make frames be dropped by moving things around and taxing my computer, and then now they're almost aligned, and now I can move it some more and it's going to be lagging behind. As you can see, it's already behind, and I move it some more and it's even more behind. And that's because once a frame has been dropped, there is no recovery from that, because previously on this version I was updating this based on when the GFX block was called, and if it was called, I was updating. If it was not called, that frame was lost forever, and this increment on this coordinate was lost forever. That's no good. So what I'm doing now instead is I am catching things up to where they should be. This is me trying to catch things up based on the relationship between the audio thread and the video thread. But I'm trying to catch things up to where they should be. So if I drop a frame now, I haven't refreshed yet, but when I refresh, if things work out correctly, when I drop a frame on the next one, I will just try to catch up to where I should have been. It's just that I will take a little bit longer. And now I think this will be a more precise experiment for what I'm looking for. I am trying to measure the difference between just doing things based on the write and the read head, based on the schedule of the threads, versus doing things based on the passing of time. So this is it continues to be our standard of correctness in terms of the position of the boxes. So this is always in the correct location. This is the one that may be drifting apart, and this is of course the one that represents our current implementation of the waveform display. Enough talking, let's see what this looks like. Okay, something is happening. The most interesting thing to me is that the box that was supposed to be below is not, so probably I made a mistake somewhere. Well, I don't know where the mistake is, but I know that I want to call this the time current. I want to call this the time previous. Does this help? Not at all, but I wanted to do it. So why is this not showing? I may have renamed the variable wrong, something like that. I don't know, but definitely the thing above here is updating more often than it should. So, oh, I think I know why even, because this is updating at the sample rate. So this is updating at my sampling rate, which is 48,000 times a second. So it's trying to move ahead 48,000 times a second. I should divide by the sample rate at some point. But first I want to recover the state. Oh, and I probably should be setting. No, I was saying that I was thinking that maybe I should be drawing the rectangle after calculating the coordinate, but that doesn't affect anything. So let's comment this block out and try again. We should still be seeing the rectangle below, and we are not. So that's odd. I'm going to investigate the variables in the program now, because the x passing of time, when it is bigger than the width, which is 200, I should be decrementing the width from the passing of time. In other words, this number shouldn't be this large. Why is it that large? Well, let's backtrack. Time, current, and previous seem to be in order. They are big numbers, but they are the number of seconds that have elapsed since the 70s, I think. So they are big numbers. That makes sense. Then we have this difference. And this should be a small number. It is a small number. And this increment should be a relatively small number as well. We should not be updating this. This increment is how much to the right we are going on every frame. So this number should not be large. If this is a large number, then the box is jumping. This should be a number around 1, which is like 1 pixel across. And that's fine. That's a small number. But so let's see how it starts. It seems like it starts with a 0, and then it immediately jumps up. And this number is almost in the same magnitude as these two numbers. Oh, I think I know what the issue is. The issue is that, to begin with, and I don't know why we haven't seen this before, probably because I had the effect open, I just reloaded it. I don't know. You would have to rewind the stream to actually see what happened before and why this was working before, but the issue here seems to be that on the first time we are around, the first time we are doing this, then the time current and the time previous, they're both 0, So we get here and we have a time that is a big number, and then we subtract the big number from 0 and we get the big number. So on the very first frame, the box is all the way to the right. That's no good. So, oh, and I should have, no, I should not. So yeah, this is probably the mistake. So I guess we can check over here if it is 0. And I think we had something to that effect in our previous implementation when we started playing around with this whole notion of time. I think we had something like this. So now we have this that is going to check, is this the first time around? Is the time previous equals to 0? In that case, let me set both times to be exactly the same. So this subtraction is going to be exactly 0, and to begin with, the x-coordinate is exactly 0. That should do it. Okay, so now the coordinates are much smaller and between 0 and 200. And now the box is again moving as it should. Now, don't ask me why it worked before, but there you are. Now, let's reason about this fellow. This is moving across too fast, and it has to do with, I guess I just have to multiply by the sample rate. I don't know, I'm just guessing, but okay, now it's too the number is too small because it's not moving across at all. Oh crap. Well, it's not moving. Oh, it is moving. It is moving. See this black column here? Oh, you just saw it moved. It moved right in front of your eyes. It's moving. It's moving too slowly, however, but it's moving. So maybe dividing by the refresh rate is no good, because this isn't based on the refresh rate to begin with. It is only, well, it is based on the refresh rate, but it's only based on the relationship between the refresh rate of this guy and the sample block. So it gets a bit deeper than just using the refresh rate. But I don't think that this helps, because that was not division by 60 yet. So it is moving across, but it's still moving too slowly. I'm multiplying, or I'm dividing by something that I shouldn't be. I will remove that division and see if that helps, but it won't. It will make things slightly faster, but not by much. Now I'm moving the screen around just to see if this box is gonna start jittering in weird ways. Oh crap, I think I will have to think. Just trying to write code and see what it does is not gonna cut it this time again. Okay, let's think then. I want the refresh rate here, this X refresh rate. I want it to go from 0 to 200, or to 0 to width, in 3 seconds. For that to happen, I have to also reason in terms of the read index and the write index. By the way, is this number big enough? Yeah, let's think about this number to begin with. Is this number big enough? This number needs to be big enough so that this is not going to wrap around. Hopefully, we are going to be writing and reading relatively in sync, but there is a difference between the 60 frames per second and the 48,000 hertz sample rate. So I am, for every 48,000 samples, I am refreshing the screen 60 times. So my circular buffer needs to be at least 800 samples. I will make it 2000 or maybe 8000 just in case. So now we are sure that the right index, or we are not sure, but we hope that our right index will not be able to wrap around and take a lap around the read index. That's part of the issue. Then, this update, there is nothing to think about. It's just incrementing the right index. That's easy. This is just catching up. So the read index is following the write index. And this is also correct. So this is the only line that we really have to think about. This is where we are going to spend the next couple minutes. We are going to run this line. Suppose that instead of a refresh rate of 60, I had a refresh rate of 1. In that case, we are calling this once a second. What has happened in that second? Never mind the issue that this is not big enough for a frame rate of 1 second, because we have taken care of that already. So suppose that 1 second has passed. How far do we want to go? Well, we want to go 200 divided by 3. So if this was called every second, I would like to move width divided by duration. That would give me the right formula for 60 frames, for 1 frame per second. But that's not all, because this block of code is in a while loop. And this while loop is going to run this block of code several times. How many times? Well, suppose that we have enough buffer size to run this a whole second, and suppose that the catching up is going to work just fine. So how many times are we going to run this line of code? 48,000, because there will be 48,000 samples in our buffer, our circular buffer. We'll have 1 second worth of audio, 48,000. So we don't want to increment this much all at once. We want to divide this by 48,000, which is the sample rate. And that may wrap things up, because this formula involves the width and the duration and the sample rate. So I think that this is the formula I need. And there you have it. It was the formula I needed. Great. Yay, Leandro, you did it again. Now the two boxes are sort of in sync. At least they're not drifting apart unboundedly, I don't think. I don't think I can make it. I don't think I can make these boxes drift apart like they were before. Even if they jitter a little bit, or if one refreshes differently from the other or whatever, I think that I cannot make them drift apart, no matter what I do in terms of what I'm doing on the machine. Frames are being dropped, I'm pretty sure, because frames were being dropped before. Frames are being dropped now, but at least this one still catches up to the one below. Okay, yeah. This is a fun experiment. I'm having a lot of fun making these blocks move across the screen. Are you having fun too? I hope you're enjoying this. Blocks moving across the screen is where it's at these days. All right, so let's do the judgment again. How is the jitter? How is the drifting even? Are they drifting apart? I don't know if you can see this on YouTube, or maybe even if you were here by my side, you maybe would disagree with me. But I think I see a difference between the two. Let's put them next to one another again. And never mind that one is a bit ahead. Tail is here and says, what are we doing, drawing sprites? Yeah, so Tail, I think you were here for last time when I was doing the waveform display, and I took the shortcut of just not bothering with the whole split index situation, the passing of time and whatever. Yeah, I couldn't help myself. I decided to explore that further. So this is an experiment, and the box below is updating based on that idea of the split index. So it's based on time precise. This box is updating based on the time. The box above is based on that whole concept of circular buffer allowing communication between the audio and the user interface threads. So the audio thread is pretending to write into a circular buffer. The user interface thread is pretending to read from that circular buffer and catching up. The read head is catching up to the write head, and it's updating the screen accordingly. So the timing of the box below is completely based on the clock on the wall. The timing of the box above is based on the concurrency between the audio and the user interface threads. That's what's up. And I'm just not drawing anything interesting. It's just a bunch of boxes, but that's what's up. I wanted to isolate the issue to see better what's going on and to determine whether it was worth it to dive deeper into that whole idea of the split index and everything. And over there on Bo is saying that probably, maybe because of YouTube and everything, but he doesn't see a lot of difference between the two. I will actually rewatch this later to see if I see a difference on YouTube, but I do see a difference here in front of me. The one below seems to be smoother than the one above. And I was saying before I started commenting on Tails' chat message that never mind that the one above is a bit ahead of the one below, that is not a problem at all. It just has to do with how things started to begin with. But the important thing is that now this is implemented correctly, they're not drifting apart unboundedly. So, for instance, in the waveform display, I could have a scratch space, coming back to that idea of the scratch space, which helps to align stuff. Oh, see, now it's a bit behind. Interesting, but can I make it drift apart unboundedly? Oh, I can. Oh, zooming in and out takes resources from my GPU probably. And that makes the boxes drift apart unboundedly. Yeah, just by zooming in and out, I can make them realign, and I can make them drift apart again. Interesting. That's surprising to me. I wasn't expecting that. Because we are catching up to the frames we have dropped. So this should not be happening. Oh, and the whole zooming in thing is doing weird things to my second display. When I zoom in here, can you see that? You're starting to see my second display. It's completely glitched out. Huh, interesting. Well, whatever. I guess I will have, though, to just do one bit so I can see the chat again. Because my second display died. Well, I was stress testing my GPU, so to speak, so whatever. But yeah, this drifting apart is breaking my heart. Because it means that no amount of scratch space will save us from this. There is no way for me really to implement this split index correctly. But why is this happening? Because we are supposed to be catching up to the samples we lost because of a frame that has dropped. Let's make this bigger. So let's suppose that we are very unlikely to run out of buffer size, because my theory is maybe the circular buffer is not big enough, so it's taking one lap. The read head is behind the write head so much that the write head has taken a lap, and that's what's causing the desynchronization? Maybe. Just making the circular buffer really big will help on that, I think. Okay, they are in sync. Oh, there you go. Seems like I was right. It was just running out of the circular buffer. So we were dropping too many frames, and then the thing desynced. And if we implement the split index situation here, and we implement this notion of looking at the clock, we will have to do something to prevent this kind of desynchronization. We'll probably have to see if our scratch space has been exhausted. We'll just introduce a dropout in the middle of the waveform drawing, because we have run out of buffer space. Very interesting theory and very interesting experiment here. I am finding this fascinating. Learning a lot about JS effects, really. Not the language, but the practice of it. Okay, I think that we implemented this right now. It's even if I move things around and I play around with the screen and everything, it's not getting out of sync. Perfect. This is what I wanted. And never mind that one is a little bit ahead. As long as this is bounded, as long as the drift between the two is not unbounded, we are good. We can get away with a scratch space situation going on. Now, what do we do? Do we implement this split index or not? I think we will. I think I will have to bite the bullet and do it right and do this idea of the scratch space, look at the time, look at the clock, and even detect whether we have run out of scratch space and resync things, because we are going to desync stuff. There is a pretty easy way for me to desync stuff, and it's something we have seen before. If I just go to another plugin, then my GFX block is not running at all. And in that case, when I come back, they are way out of sync. But they are out of sync by an offset that is constant. And that's the big deal. So as long as I have some notion of resyncing, which is necessary when I go to another plugin and come back, it's necessary when they get too much out of sync because I have exhausted the buffer or whatever the case may be. As long as I implement this notion of resync, they're going to continue in sync. So see, they are this much apart, but I cannot make one take laps around the other, no matter what I do on taking more resources. This one is always behind by like 3 cursors. I guess that is the story for today. I'm going to wrap things up now, but the conclusion is, I think it's worth it to do it. I think it's worth to do this whole situation of looking at the clock. I will think more about this and we'll see when I come back. But the schedule is, tomorrow I will be here with Aria, hopefully. That's the plan anyway. And we will continue to work on our pitch shifter. So for something completely different, we will be working on the pitch shifter. Then on Wednesday, I will return to this. I'm not sure what I'm going to do, if I'm going to do this passing of time situation, if I will do something else entirely. We do have to look at rectified waveforms and thicker contours, and it will be waveform extravaganza again. Thank you all for being here. So thank you, Bo and Tail and Joseph and everyone else who is watching this. And I will see you again tomorrow for some more JS effects. It's going to be a lot of fun. And I see you on Wednesday for more of this waveform situation. We'll see what it will be. So thank you all for being here. Thanks for joining me. Thanks for being active on the chat. That's very nice of you all to join me on this ride. And I see you tomorrow, same time. Bye. Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.